Hello everyone, my name is Arun and welcome to my channel. This series is a series of tutorials on C programming, and in this tutorial we'll be talking about some primary data types, data prefixes that are available in C. Now the primary data types that are available in C are int, character and float. Double is actually an extension of the float data type. Okay. Now nevertheless the primary data types are actually three: int or integer, which helps us to store integral numbers, meaning numbers which does not have any fractional part in them; character, which actually helps us to store single special characters, and also numbers with a small finite array of numbers, finite range of numbers. And then you have the float variable, which helps us to store both positive and negative numbers with different decimal parts. Okay. And now in our day-to-day application with programming, the range of numbers stored by these integers, characters and float, okay, by default may not be sufficient, and you might require them to store larger range of numbers, or you might demand them to have much higher precision in case if you're working with float and double. Okay, in that case, okay, that can be this is possible by using the data prefixes. Okay, some of the primary data prefixes that are available are okay, I think I forgot this. Prefixes are long, short, signed, unsigned, long. Okay, so these are the ones that are available, so let's look at them. So what these prefixes do is that once you put these prefixes in front of the data type, let's say int, character or float, then the variables that get generated through this data type are much enhanced. They tend to have larger memory or shorter memory, and then to store have a higher precision and can store more numbers or more range of numbers, or lesser precision, lesser range of numbers, depending upon the keyword that you're using. Okay, now let's look at them one by one. First thing which we look at is the long prefix. So what I have here is I have a variable, so let me put this as int. Okay, and now I'm just printing out the amount of bytes it takes to store this variable I1. So to do that, I have this function sizeof, which is also written inside stdio.h. okay, .c file, since I included this, so I can directly use this. So if I compile, build and execute this, that sizeof function will tell me how much memory the variable I1 is actually occupying. Since it's a single variable and it's an integer, it's occupying 4 bytes of memory, and that is how the notation. Integer usually takes 4 bytes of memory. In some rare machine configurations, they might take 8 bytes of memory. In some rare machine configuration, keep that in mind. Okay. Now, with that being said, what happens if I put the keyword long in front of it? I compile, build and execute this, and if I look at it, turns out now the integer data takes 8 bytes of memory. Okay, interesting. The moment I put a keyword long in front of it, the integer takes more memory. Okay, as a consequence, okay, the more memory it takes, the more range of numbers it can store. So the earlier int, let's say, has some kind of a limiting value up to which it can store. Okay, long int will make sure that you can store more numbers, okay, larger numbers. And there's also this extension called as long. This is also possible. In my system, I don't think there's going to be much difference. So long int, it also points to an 8-byte integer. Okay, but in your systems, based on your configuration, long int might give you an integer which has more larger data, which might occupy more memory than the usual integer. Alright. Okay, and also by default, if you don't give the keyword, if you don't give any data type like int or let's say just give the name long, that itself is sufficient, because that itself creates a integer, and it's going to create an 8-byte integer. Okay, so if you give a long, you don't have to specify it. If you don't have to specify it, the compiler automatically assumes that to be an integer occupying 8 bytes of memory. That's it. Now there's also an equivalent one called a short, which performs the exact opposite of long. So if you put short, the data type, the variables tend to occupy only 2 bytes of memory. The integer tends to occupy only 2 bytes of memory. Alright. And now, so short itself acts as a 2-byte integer. So if I put a short int over here, at least in my operating system, they don't make much difference. Okay. The moment I put that's about it. And thing is, I cannot put two contrasting data types together, like short and long. I cannot put them together. If I put them, it will immediately give me an error, because these two are mutually exclusive. Okay, you cannot have both of them together like that. Okay, now depending upon your operating system, the kind of the machine level implementation in your operating system, in your machine, the hardware configuration, and the C compiler that you use. Okay, you might come across several combinations of short and long with the integer, like just plain short, or short int, or just int, long int, long, or sometimes even long int. Okay, in my system, short and short int are exactly the same. Long int, long, and long int are exactly the same, whereas int is separate. So in my system, for my C configuration, just short int, short int is I can, if I want to write a short integer, I can use either short int or short. It'll work the same. If I want a long integer, I can write long or long int, or any one of these four. It'll work the same. And if I want this as a plain integer, I can just use int like this. However, in your operating systems, based on your configuration, C compiler usage and all, these might be different. In general, short occupies less memory, or or the same memory as that of short int, and short int occupies less memory, or less memory, or the same in memory as that of integer. Integer occupies the same or less memory than that of long, and so on and so forth. Okay, so this is like a thumb rule you can keep in mind in the future. Also this short and long keywords are also applicable to character, but in my operating system they don't work. There's only character occupies just only 1 byte of memory, so there's no point having a short character and a long character. Okay, so they don't work. Okay, but in some operating systems, let's say in some configurations, this might be possible, or in some non-standard C implementations. Okay, this might be possible. In general, by putting long and short in front of the keyword, in front of the basic data types int and character, you tend to increase the size or decrease the size, thereby changing the range of values that can be stored by them. Now here comes two more new keywords, signed and unsigned. Now the difference between signed and unsigned is, as the name suggests, is just the sign convention. Now by default, unless otherwise stated, all the variables that you create in C are actually signed, meaning they can store both positive and negative values. Alright. Now the moment you put the keyword unsigned, what will happen is that they can just store only numbers without any sign convention. They can store numbers without any sign convention. What happens under the hood is that whenever you create a variable, each variable occupies certain bytes of memory, and since 1 byte equals 8 bits, okay, depending upon the number of bytes, okay, they have certain number of bits for each variable, and whenever a variable is created by default, one of the bit, either in the leftmost end or in the rightmost end, okay, is actually used for the sign convention, meaning to store the sign. So if that sign storing bit is 0, let's say, it may be positive. If it's 1, then it means that the number is a negative number. Okay, that is used. When you put the keyword unsigned in front of it, it just automatically makes sure that byte which is used for storing this sign gets stripped off, and it comes to store the data. As a consequence, those numbers, when the moment you put an unsigned keyword in front of them, they cannot be used to store positive or negative numbers. They just store numbers which do not have any sign. So by default, you can assume them to be positive numbers, but you just have, if you want to use them as negative numbers, you have to be cautious. So what unsigned does is that it just readjusts the way numbers are being stored inside the bytes, thereby and removes the bit that stores the sign, thereby making possible some extra numbers to be available. Because of that one extra byte, you tend to have twice the range of the normal numbers. So if you have a signed variable, let's say, and if the n is the number of bytes taken by the integer or a character, okay, signed variable, number range that you can store using a signed variable is given by this expression. So the lowest number, the negative number that can be stored, is given by minus 2 power 8 star n minus 1. Okay, 8 star n minus 1. Okay, and the highest number that can be stored is 2 power 8 star n minus 1 minus 1. Okay, this minus 1 is because you need a number to store a 0, and that's why you get like that. Okay, on the other hand, if you want to store if you want to store an unsigned number, let's say, okay, the lowest number that can be stored is 0, and the highest number that can be stored is 2 power 8 star n, and then a minus 1 at the end. Okay, and that's about it, and that's how you get different numbers. Also in a float type, okay, a float takes 4 bytes of memory, and as we saw in the one of the previous tutorials, double takes twice the memory, and long double is available and it takes twice the memory of the double. So long double actually takes 16 bytes of memory. So just let's check this out. If I type long double and then I compile, build and execute this, check this out. Now this variable takes 16 bytes of memory. Cool. Now instead of the variable, I can also type something like long double and all. Okay, size of function can take both variable names, and it can also take the data type names together, so it doesn't matter, it won't throw an error. Okay, let's see, what mistake. Yeah, it's just a warning saying that I didn't use it. Anyway, if you look at it, it still works. Okay, that's about in this video. And now just to give you some contents that you can read through. Okay, there is this Wikipedia article that explains what an integer is, and especially with respect to computer science, and in some implementations of C, C++, C#, Pascal and Delphi, in this article tells us how are those numbers being represented and what do they are called as. Okay, so you might come across with different numbers. For instance, a half a byte integer of just 4 byte number is sometimes called as a semi-octet or a nibble. 1 byte integer is actually called as a byte or an octet. Okay, octet. And there's half word, word, short, and short is actually the keyword that is used in C, C++. Okay, and 32-bit integers are given by the name int, long, double word, long word, like that, and that depends on the different languages of usage. Different C programming languages that you use. And in C it's called as int, and sometimes it's also called as long, depending upon which C language you're using. Okay, which C language you're using. So it's a language implementation thing. And similarly, the 64-bit integer is actually called as long or a long, or just a quad or an int64. And that too, these depend upon the C language implementations. Okay, and the range of number that they can be stored is actually given over here. So they give a general case at the bottom. So if it's a signed variable, signed value, if n is the number of bits, okay, this is the lowest number that can be stored, and this is the highest number that can be stored. Okay, and this is the largest. This is the unsigned value. The smallest number that can be stored is 0. The largest number by magnitude that can be stored is 2 power n minus 1. Okay, so these are the numbers. And if you want to look at the data types that are available in C, okay, these are the data types that are completely available, like character, assigned character and unsigned character. Okay, maybe in some non-standard C implementations, short character, a character and long character might be available. In general they are not, but in some non-standard implementations it might be available. You can just have a look at that. Okay, it's not it's not something you have to seriously look upon. Just giving you some no, giving you some idea that it can exist. Okay, and then as far as the integers are concerned, you have several of them over here, like short, shortened, signed short, signed shortened, and all. These are the different ones available, and the explanation of what this is and the range of numbers that they can store as far as the integers are concerned. And at the bottom they also have the numbers for float, double, and long double. Okay, and how much the values they can store and all. And if you want to know the precise method in which the numbers are stored inside float, double, and long double, you have to go to this IEEE 754 standard to get that idea. And also in some cases, hold on, let's see, hold on, I was just reading through some other, I just read through some other article. What was it? Well, I guess that will, yeah. And there's this one more article over here which I wanted to show. Okay, this is actually from this website Code for Win, wherein they also specify some format specifiers for the corresponding variables. Okay, and this is what we're going to talk about in the next video, the format specifiers. So I'll put these links in the video description so that you can have a look at it and keep a note of it. Okay, this will be very useful in the future, especially if you're working with the different types of data. Okay, we'll talk about some basic data types with we'll talk about format specifiers in 2 videos. In the first video we'll be talking about how to use them, what is the difference between them. In the second, we'll be using the format specifier to manipulate the way the data gets represented in the computer. Represented on the screen. Okay, sorry. With that being said, that's all I have for you all in this video. Thank you guys for watching, and I'll see you guys next time.